All right, today I want to talk about cameras. Let me get a share screen going. So with cameras, um, I have a scene over here and I've got a camera in the scene. Um, Cameras can see everything that's inside their viewing volume. And their viewing volume is a truncated pyramid or frustum. Let me put this in wire frame so that we can see the gizmos a little better. So here's my camera. You can see this viewing volume that is this truncated pyramid. You can't really see that it's a pyramid because I have the near clipping plane very small, but if I make this bigger, you can see that it truncates out to this pyramid volume that which we can see everything that's inside that volume. So, whoops. So if I move that out far enough, you'll see that the scene begins to disappear here as I'm moving my clipping plane out and I'm not seeing anything that's in front of it. There's also a far clipping plane. Let me set that back to 0. It actually won't go any smaller than 0.01 for reasons that you don't need to know at this point. The far clipping plane is, if I make this smaller, make it like 50 and pull it back down, you can see things in the distance begin to disappear. The clipping planes, in general, you should make the near plane as far from the camera, as big as possible, and the far distance as small as possible. This has an effect on depth testing in the mathematics of projection. So I'll set that back to what it was, 0. But generally the defaults are okay. But if you're making a big world, you're going to see that things in the far distance disappear. Another feature is the clear flags. The clear flags is what we see in the far distance. Let me tilt my camera up here so that I can see some of the sky. And the clear flags is either the skybox. This is our procedural skybox that makes a realistic looking sky, or it can be a solid color, in which case you get to pick the color from one of these color picking things. I like the skybox. The culling mask lets you limit what layers you can see. Somewhere I made a custom ignore layer and lerps, both lerps, and I think this ball are in the custom ignore layers. And in the camera here, if I turn off the custom ignore, both lerps and the ball disappear. They're still there, but the camera can't see them. So I'll turn that back on again so that we can see lerps. Another feature is the viewport. This determines where the camera appears on the screen. I can make the, whoops, don't make it too small, 0.5. I can make it its width 0.5, and I can move it to where I want in my window. X and Y are the lower left-hand corner going from 0 to 1, and W and H are the width and height also going from 0 to 1. So a full screen camera is 0, 0, 1, 1. By the way, all of this can be fiddled with here in the in the scene view, I have these handles that I can kind of use to grab my uh, my field of view there, which for a perspective camera, that's the kind of camera we're looking at, the field of view is how wide an angle we have for the camera. If we make this very wide, we have a wide angle camera. If I make it very small, we have kind of a telephoto camera. You can also do this with a physical camera where you have settings for the sensor type, the lens, some other things. I'll let you explore that yourself. Now, projection is either orthographic, where there's no vanishing point, or perspective, which is what I have here. Let me set this back to about 45. That's a more or less standard field of view. I have another camera here, a top-down camera, which I've put somewhere up in the world, here. And this is an orthographic camera. And an orthographic camera doesn't have perspective. So its viewing volume, and it sees everything that's in that volume, is now a rectangle instead of a pyramid. And instead of having a field of view, it has a size. So I can adjust the size of this thing to get what I want here. It also has near and far clipping planes, and it also has a viewport rectangle, which I've set to be 1/4 wide and 1/2 high. And it's at 0, 0, so it's in the lower left-hand corner. Now, if you're going to have more than one camera in a scene, you have to account for the order that the cameras are rendered. And this is determined by their depth. The rendering starts off with the lowest numbers and works up to higher. So my main camera has a depth of -1, and my top-down camera has a depth of 0. So it's going to render the -1 camera first, and then on top of that, render the 0 depth camera, so that they're the right order. If this were a -2, it disappears because it's rendered first, and then the main camera is rendered on top of it. Now, with this, this little feature is a picture-in-picture kind of camera. We have the main camera that's watching the scene, and we have a top-down camera that's acting kind of as a map that we can see. So picture-in-picture. Now, with more than one camera, for instance, with this map view camera that looks down on the scene, you notice I've turned it by 90 degrees and pointed it down. I've adjusted its angle so it's upright in the way that I want it to be. And one issue that you might encounter is if I run this, let me turn the console on here, and I won't maximize it. I'm going to see some error messages here, well, warnings, that there are 2 audio listeners in the scene. And a camera by default, when you make it, has an audio listener component on it. And this is where the sound in Unity is picked up. Unity sound is all 3-dimensional. So something far away, you won't be able to hear as loud as something that's up near. And there's even stereo, so that you'll hear things coming more from the right or from the left if you have headsets on. So the reason we're getting this console error to listeners is that both these cameras have audio listeners. So I have to turn one of them off. And I turned off the listener on the overhead camera. Often with cameras, we have scripts that control how the camera works. And I'm going to show you a very simple script here, the smooth look at script. And I'll show you that I've made a little pull down here where I can access this script. This is an addition that I've added to the Unity editor, my own addition to the component menu. So that script looks like this. We have various usings that are part of the that tell it what components to use. In general, the defaults are appropriate. I have a directive, add component menu, camera control, smooth look at. Adding this to a script makes it appear up here in the camera control menu. There are a couple of public variables. These are things that show in the inspector. And then I have a late update function, a function that runs once per frame as we're going through this. I won't talk about too much of this stuff until later, but these are some tricks to get the camera's orientation to look at a target. And we've got a Boolean if the target, if smooth is true, then it's going to do this kind of slurping, that's spherical linear interpolation. Otherwise, it's just going to look directly at it. So I've got this script, I've written it, and I want to now add it to the camera. There are a number of ways I can do this. I can do it from my little pull down menu where I add the script to the object. Here are those exposed variables. The target has not been set yet, damping how rapidly the camera follows our object is 6. And I'm using the smoothing option of this script. I've got a little sphere here. I've got a rigid body on the sphere, so it's going to bounce around. So I can take that sphere and drop it into the, whoops, put it on the wrong camera. I don't want it to look at that. So I'm going to put it on this camera. And another way to put scripts on an object is to drag and drop them out of the project. So I can drag this over and drop it in here. And now we have a smooth look at script on this. There are other ways to do this too. So I'm going to take my little sphere and I'm going to drop this into the exposed variable for the target. I'm going to drop the sphere into the target. And now when I run this, let me maximize this, the camera is going to follow the ball. And it's not following it scrupulously because I've got a little bit of damping. So it's not following it scrupulously. But it does follow it wherever it goes. Now, often instead of following some object, we want to follow our character. And so I can drop lerps in here, and now the camera will follow lerps wherever he goes, which is all pretty cool. Gets a little weird if you get right underneath the camera. Behaves a little strangely there. Okay, so I had the sphere with a physics rigid body on it. This makes it fall. I had a bouncy material that I added to that sphere to make it bounce. We dealt with the 2 audio listener warning. And so all of this works. Now, another interesting thing you can do with cameras, let me save this scene and move to a different scene here, render textures. Something that you can do with cameras, rather than rendering to the game view, you can render directly to a texture. This texture can then be used on a material, and you can put that material on an object in the scene. To do this, you have to first create a render texture. This is done down here. We create a render texture, and I've already created one here somewhere under materials, maybe. Yeah, textures. I've already created a render texture. I've called it map texture. And since I've already run this game, it already has something in it. But this is rendered by the top-down camera, the map camera in my game. So rather than displaying this map camera as a picture-in-picture, I'm rendering it to the map texture. And that map texture I've put on a material, the map material whose texture, if it settles down here, sorry, it didn't like something that I did. There we go. So I have this material, and the material uses an unlit texture shader, and unlit means that it won't have shadows and so forth on it. And I just dropped that texture into this slot, making this material, which I then put on a canvas. No, I put it on an object on my character here. I've got this picture. This is my picture frame, which I've made part of the character and placed it kind of in front of the character here. And on that object, I've put the overhead map material. I've got another simple script called isVisible that is going to toggle whether I can see this thing on or off. So the usual usings, here's the isVisible mono behavior. A public visible is true, and a private variable, this won't show in the inspector. And in start, I get the component, the mesh renderer. I set it to be whatever the Boolean visible is, enabling it. And in update, I watch for the M key to be pressed, in which case I toggle the truthness of whether that mesh renderer is enabled or not. And we'll do much more on scripting later. I'm moving very quickly on this. So on my picture, I've got this set to be initially visible. So if I play here in this scene, I've got this nice map. The arrow is a device that I put up above me somewhere in space so that I can see where my character is on the map. And with the M key, I can toggle that on or off, and whether I get to see the map or not. Over here, I've got a little volcanic lake with lights and stuff. We'll talk about lights and so forth later. So that's pretty cool. And this might be the kind of tool that you would sell in your game as a person's abilities upgraded them. They would get access to a map that would help them navigate within the world. And that's all kind of cool. So I'm going to stop there. We'll pick up with lights next time. I'm going to stop sharing. And I'm going to end the recording, and I'll see you all in class. Bye.